Hello, this is Mr. Ferreira, and I'm going to be talking you through another part of research methods. It's on the presentation and display of quantitative data. Now, in most cases, quantitative data is going to be given to us in some kind of table or some kind of graph. Now, of course, in terms of asking you to draw up a table, this is going to be difficult for them to do because we will not be able to give you a massive amount of raw data. Though, of course, this is something which we can be expected to do, so therefore we need to think about. But there's one particular type of table that you may not know about, and it's called a contingency table. And it uses a specific type of data that can be counted or tallied. And in year 13, we're going to talk through something like this in terms of categories. That's called nominal data. And I just wanted to kind of show you an example of a contingency table. So we see here in terms of tallies and categories, we have a 2x3 table. Now, of course, I have these extra kind of dotted lines which refer to the tables. And the reason I've not kind of added in the full lines is because they don't get counted. Because we see we have 1 and 2 and 1, 2, 3. So this is a 2x3 contingency table. And what we have here is a category of guilty or not guilty. So therefore you cannot be in both categories. So therefore we could say that 5 people voted guilty and 7 people voted not guilty for the category of no eyewitness. So we see that also down the left-hand side, we also have 3 categories of no eyewitness, an eyewitness that is good, and an eyewitness that is poor or discredited. And we see that ultimately this, all that we can do is to kind of read off it. So for example, we can say this 5 represents those that we counted to vote not guilty that had a poor eyewitness. And in lessons, I might kind of explain a bit more about how this was a very interesting study by Loftus, where she demonstrated that even a poor eyewitness does influence the outcome of a trial towards guilty. So it doesn't matter whether you call it a 2x3 or 3x2. What we do have is literally 3 rows and 2 columns, or 2 columns and 3 rows. The same thing happens for each of these. Now, of course, a contingency table is the one type of table that they could easily ask you to draw, because they could say, you know, out of 12 jurors, they have 7 saying guilty. And then therefore you can say, okay, so that means 5 said not guilty. But what they're more likely to do is to take a table like this and ask you to read off it. So you might have to interpret it. So you might need to look down at country 1, 2, and 3, and you see, okay, so for example, country 2 has a significantly more number of studies. And so therefore the trend of secure being 65%, insecure avoidant 21%, and insecure resistant being 14% could be seen as happening in the majority of countries. And so that's how we use these particular tables. We refer to specifics, so I've referred to country 2 and the 18 number of studies and the percentages for each of the types of attachment. So therefore we could perhaps make some kind of comment about how country 1 and country 3 have secure attachment of being 64% and 67%, which is significantly higher than any of the other percentages. But we see that there's an interchange between insecure avoidant and insecure resistant, where country 3 has a significantly more insecure avoidant at 26% compared to 7%, and we see country 1 has significantly more insecure resistant at 29% compared to 7%. Okay, so those are all kind of numbers that I'm referring to and description of the table. And this is a very kind of easy type of question for them to ask you, to kind of tell the examiner what is happening in the table. Now, you'll get marks for being precise and specific. Okay, so therefore, hopefully you noticed I used kind of actual numbers from the tables, and I kind of said exactly what it is that they mean. So there we go. So we have tables that we could have. Contingency table that could ask you to draw, and other tables they could ask you to interpret. But I suppose the most common way in which they will ask you to kind of display data would be in some kind of graph. And now, of course, there's lots of different graphs that we can draw, but there's ones that we particularly like to ask about. So, for example, a scatter graph. You notice here that there seems to be a relationship between the number of hours sleeping and reaction time. So, of course, all of you should know this in terms of a correlation. So if we draw a scatter plot, we are actually looking at a relationship between two variables. They're called covariables, and so therefore it is called a correlation. Now, in the lessons, I would have asked you to draw the scatter plot for the following set of data. And historically, I've done this year after year in an exam, in a test, in a class, and people get it wrong. Now, what we need to know is that there's several ways in which they can examine this. Now, we notice here this is worth 4 marks. Okay, so that's a significant amount of marks. If you think in terms of the AES exam, that would be 4 out of 24. In terms of the A-level exam, that would be 4 out of 48. So that could actually change a grade. But what makes this one particularly even more challenging is that they actually tell you to draw a scattergram. So therefore, they could, in a different type of question, say, please draw the appropriate graph and therefore give you a table of data, and therefore 1 mark will go to drawing the correct graph. So now they've told you it's a scattergram. So we can see actually the 4 marks actually mean that this is a difficult question. So if you are not in school, I'd like you to kind of stop the video now and to attempt to draw this. Okay, so I'm hoping that you actually attempted to draw this, because I'm pretty confident that the majority of you would have got it wrong. And this is not me trying to be kind of mean and nasty or even arrogant. It's because I know exactly what is going on here. What is happening is that many of you are being distracted by this idea of time slots. And so therefore you've either drawn more than one set of dots or squares or triangles or crosses, and you've tried to draw it for observer A and observer B, compared to, so you've done something like this, compared to, so you've got time slots here, and you've got observer A and B maybe over there, okay? And I'm really sorry to say that this is horribly wrong, okay? What we do have to do is look at the question. What are we comparing? If we go back to this particular one, we're comparing reaction time with hours slept. Now, it happens to be the same person who does the reaction time and the hours slept. So let's go back to this particular table, and it says observation of 1 child, number of verbal aggressive acts in 10-minute time intervals. So in other words, the time intervals is a kind of a bit like when we would have participant 1, participant 2, participant 3, 4, 5, and 6. And so therefore, with this being completely wrong, we need to consider that I'm trying to actually compare or see the relationship between A and B. Okay, and we look here, this is drawn for us in terms of the exam. We see observer A versus observer B and observer B versus observer A. And what is quite good here is just the recognition. Remember, I told you scatter plots are looking for a relationship or a correlation. Now we can easily say the correlation here was a positive. Oopsie, I've made a mistake, haven't I? That's a negative correlation. So in other words, as one value goes up, the other one goes down. But go back to this. Is there a relationship between the data? And I'm afraid to say that there isn't. This question was actually about you seeing that the 2 observers seem to actually observe the same child and yet come up with different results. So I know that for GCSEs, that correlation can certainly be seen as being quite simple and straightforward, and I still want you to kind of recognize that. But of course, in psychology, correlations can tell us a significant amount of what is going on. And so therefore, please be wary and look out for the meaning of correlation. As I said, looking at the relationship between covariables. What is it that they're actually asking us to do? And therefore, those graphs should actually be a lot easier to do in that particular context. So scatter plot. It's definitely one of the graphs that they could definitely ask you to do. The next one is a bar chart, and I suppose this is the most common type of graph used in many circumstances. We see an example like this, and we see what is very, very important here is that each bar is kind of independent of each other. Okay, so we mustn't make the bars touch each other, and it's very, very important here that there must be a bit of space, because as it's not a bar chart if you don't do that. And what is quite clear from this particular diagram, we can quite clearly see it's about food preferences, and we can see potentially that chocolate is the most number of participants who liked chocolate over pizza and chips and things like that. So the bar's heights represents what it is that we're having a look at. And I think probably the best way for you to have a look at it is to practice it. So then the next type would be something called a histogram. Now, I'm not actually going to focus too much on histograms. This is just an example of a histogram, and you see the relationship between the different values there. Now, there's never been a histogram expected of you in terms of an exam, and that's because obviously it's the area under the curve that becomes quite important. And my feelings are quite obviously that this might be something that would be very challenging for most of the psychology teachers to teach. And even for you within your own GCSE maths, you probably struggle with this unless you're in the top set of maths. So therefore, I'm going to kind of make a judgment about histograms. However, I'm going to show you something right at the end where a histogram is relevant, but it's relevant in a different particular way. So the two types of graphs you're going to be asked to do, mostly speaking, are going to be bar charts and scatter plots. And so therefore, in terms of the lessons, I'm going to ask you to draw a bar chart, a scatter plot, and then I do ask you to draw a bit of a histogram, but I kind of think it needs to be simplified. I don't want you to correct the widths of the columns. I just want you to kind of draw what you see. If you feel that these examples are kind of not challenging enough, let's look at an actual exam question from June 2012. This one's quite nice. It's quite clearly, we're looking at mathematical ability and musical ability, and we see that there's a relationship, or we see that they're trying to find a relationship between the two. And so it says, in your answer book, sketch a graph to show the data in the table. It's only worth 3 marks, so therefore it must be quite a simple answer, because one, we have to decide that it's a scatter plot, and two, we have to draw it, and we see actually it is. I can't remember whether there is actual relationship between the two, but what we're trying to do is get you to draw this. Okay, so there we go. We have quite a simple demonstrating that you can draw pictures to represent your data. And remember when I told you at the beginning of descriptive statistics, the reasons for this is that people can look at the data quite simply and see the picture and understand it. Now, as a kind of a last part, I do want to refer to something which is a little bit more challenging, and that is something called distributions. Okay, so for example, we're going to use the word distribution maybe to look at, you could say at the latest coronavirus, kind of in terms of infection rates, kind of where are the infections distributed, okay? And what I'm going to talk about is normal distribution, skewed distribution, okay? So normal distribution, okay, looks a bit like this. And what we see, it's kind of a classic kind of bell curve, they're called. We see the normal distribution has the highest, or the most common people in the middle of our measurement. And of course, there's extreme values that are high to the right and extreme values that are to the left. And you could say, when I look at a population data, this is the type of data we should look at. So for example, if I was looking at population age, this is kind of roughly what I would expect. Now, obviously, we do know that this is actually becoming less and less common to find this normal distribution, but we would expect in a population to find normal distributions in things like height, in terms of kind of like certain abilities, because we would expect most people to have the average ability, kind of linking to this idea of mean ability there, and then we have a few people with the extremes on either the left or right. Even in terms of intelligence, we'd say that there's an average intelligence of 100 IQ points, And of course, the higher you are, you go to the more extreme right, and the lower you are, you go to the more extreme right. And so another way to view this is that a normal distribution has the mean, median, and mode exactly meeting in the midpoint. So this is kind of when I was going through mean, median, and mode, I said I'm going to kind of come back to this in terms of distribution. So you could get a question that asks you to calculate the mean, median, and mode and make some kind of inference about its distribution. So of course, if the mean, median, and mode are pretty much the same. Now, of course, mathematically, it's very seldom that they're going to be absolutely identical, but if there's actually very little variation between them, then we could say that this is a normal distribution. But of course, not everything falls within this normal distribution. What we find is we can have a negative skew, okay, or a positive skew. And we see that the negative skews and positive skews kind of happen under different context. We see, for example, the negative skew is if something was very easy. We have more points kind of at the high level, okay? So this is where people have done very well in tests. Okay, I'd also expect that at a school like Cooper's Coburn, that we would also have this negative skew in terms of ability within this class, because you had to achieve a certain amount of GCSE grades before you could even enter into the sixth form. So therefore, even when I look at my data for psychology, I expect to get more A's, B's, and C's than I do D's, E's, and fails. And contrast, if something was potentially very difficult, what we might find is that we have more marks on the low side. Okay, now one of the reasons we could have this is, of course, I told you in terms of the mean and the median, or the mean specifically, is that the mean is potentially influenced by outliers, by values that are outside of the kind of the normal distribution, of course. And this could either, if marks are very high, we could have some of them being dragged out to the left. And if the marks are really low, that a high mark might drag it to the right. And so when we look at these graphs, I look at the negative and it says to the left. So negative is skewed to the left. But actually, it looks like it's leaning towards the right. So it's counterintuitive. And if we look at the positive, it seems like it's leaning to the left. But I've said right there, so that does seem counterintuitive. So how is it that we work out these particular graphs? Well, let's look at this one here. So for example, we should know that the green line is always in the middle. Now, think about this. Why is it always in the middle? Go back to your definition of median. Median is the middle value, so it should always be in the middle. So what then is on the left-hand side? So for example, if we look at this first one, we see that the mean is on the left-hand side. And in this one, the mean is on the right-hand side. So the mode will be the most common. So think about this also. If we got very high test scores, it means that the modal score will be bigger than the median. If we have very low test scores, the modal score will be below the median. Okay, because remember, this line represents the actual scores that people can have. Okay, so this is the typical example we would find at Cooper's, where we kind of hopefully that we would have people heading towards a kind of the top end of results rather than the bottom end of results. Now this becomes particularly relevant when we potentially get a question relating to mean, median, and mode and distribution. So if you can remember that the median's always in the middle and that we're looking at the mean value, we can forget about the mode because obviously there is only mean, median, and mode. So if I can draw the median and if I can draw the mode, then I know where the if we can draw the median and then draw the mean, I know where the mode goes. Okay, and we need to look at the shape of these two graphs. So negative skew, okay, has this particular shape, and a positive skew has this particular shape. Okay, So the last type of graph they might be able to ask you to draw is something relating to this normal distribution. And this is an example question that we have. Now this is worth 5 marks in total. Okay, so this is actually could change a grade. Okay, could give you a chance to read through the question or pause the video to read through the question. And what we find is that there's a scale of 0 to 20 representing 0 representing no investment in the relationship and 20 represent extreme investment. So they ask these people about how they feel towards being invested in a particular model. And then we see here the psychologist calculated measures of central tendency. Okay, remember I used that phrase, measures of central tendency. And we see here we have a median score of 9.5. See, 9.5 is in the middle. We have a mean score of 8.6, and we have a mode score of 13. Now also remember, mode was the only one that would actually represent one of the scores that you could have got between 0 and 20, where the median score, as obviously in an even set of numbers, is the middle point between two, and of course the mean score is obviously a calculated average. So with this, the key here is not the difficulty of sketching the graph, because it does say sketch the graph, but it gives you a clue to distribution. Okay, so think about whether you could actually draw this. Think about in terms of this, what have you seen? You potentially have seen the negative distribution shape, because the mean is lower than the median, which is lower than the mode. So therefore, what would you draw, or how could you draw this? The chances are that you could just draw the shape. You could then represent the median of 13. We could also then represent the mean of 8.6 and the mode of 13. Okay, so if we want to have a look at what the mark scheme showed us, we see mean, median, mode. They didn't even have the values in there, but you just label the graph investment and number of participants in terms of frequency. So ultimately, this question, which appears to be incredibly kind of difficult to get your head around, actually is a little bit easier. And we see it is just literally drawing the shape and putting the values of investment and frequency. And there we have it. And then the last question was asking us to say it's a negative skew. So quite a good question to ask, and certainly should separate students who perhaps have looked into this and have seen the relationship between median, mean, and a mode and distribution, and those students who haven't, and certainly those students who can remember how to do it. So therefore, I hope you have enjoyed this. It is quite a simple section, but of course it has a few intricacies that you perhaps need to think about. That's it. I'm going to finish now. Good night.